Somewhere beyond the edge of our solar system, a mysterious object is hurtling toward the sun. Faster, brighter, and stranger than anything we've ever seen. Astronomers call it 3I Atlas, the third interstellar visitor in human history. But what it's doing shouldn't be possible. It's glowing when it shouldn't, spinning like it's alive, and defying the laws of physics as if mocking our understanding of the universe. Could it be a natural wanderer from a distant star? Or something far more extraordinary? Whatever it is, one thing's certain. 3I Atlas just got stranger. A visitor from another system. When astronomers first spotted the faint streak of light in the Chilean sky back in July 2025, few realized they were witnessing history. The object, later named 3I Atlas, wasn't just another comet. It was an interstellar traveler, a visitor from beyond our solar system. But what makes this particular visitor so strange is how it seems to defy every rule we thought we understood about such objects. In the months since its discovery, telescopes around the world have turned their gaze toward this icy wanderer, trying to make sense of its behavior. What they've found has left even seasoned scientists speechless. 3I Atlas is brighter, faster, and chemically stranger than anything we've seen before. And as it nears its closest approach to the sun, the mystery only deepens. Imagine an ancient fragment of another star system, an object that formed billions of years ago in the cold outskirts of some distant sun, only to be hurled through the void and into our neighborhood. What stories could it tell about its home? What secrets might it carry, frozen in its core? But as with all good mysteries, each answer about 3I Atlas seems to raise 10 more questions. What is this object truly made of? How did it achieve its impossible speed? And most puzzling of all, why is it acting like no comet ever observed before? Today we're diving deep into this enigma. From Hubble's stunning images to James Webb's revelations, from bizarre chemistry to alien theories, we'll uncover why 3I Atlas has become the most puzzling interstellar object yet. This is a journey through science, speculation, and the strange beauty of the unknown. So buckle up, because this is not just another comet story. It's a glimpse into something much larger, perhaps even cosmic history itself. 3I Atlas has already shattered expectations. Now it's about to rewrite what we know about the universe. Every observation brings us closer to understanding. But for now, one thing is certain. This visitor from the stars is far from ordinary. And as it races toward the sun, it's only getting stranger. By the end of this journey, you'll see why astronomers are calling 3I Atlas the most confusing discovery of the decade. It's not just a comet, it's a challenge to everything we thought we knew about the cosmos. And just maybe, as you'll soon find out, it could also be a sign of something even more extraordinary. The discovery that changed everything. It all began on a quiet winter night at the Atlas Observatory in Rio Hurtado, Chile. The telescope system, designed to detect potentially hazardous asteroids, picked up an object moving at an unusually high velocity across the starfield. Within hours, data confirmed something remarkable. Its trajectory was hyperbolic, meaning it wasn't bound by the sun's gravity. This thing came from outside our solar system. That's why astronomers quickly classified it as 3I Atlas, the third interstellar object ever discovered, following Oumuamua in 2017 and Borisov in 2019. Yet even from the start, it was clear this wasn't going to be just another entry in the record books. Unlike its predecessors, 3I Atlas was far more energetic and active, producing a visible coma and tail almost immediately after detection. This indicated strong outgassing, an unexpected feature for something supposedly frozen in deep space for billions of years. In the following days, observatories across the globe joined in. Gemini, Subaru, Hubble, and even the James Webb Space Telescope. Each instrument contributed a piece of the puzzle, revealing a traveler unlike any other. Its orbit suggested it entered the solar system from the direction of the constellation Pyxis, passing between Mars and Jupiter before swinging toward the inner solar system. But what fascinated scientists most was how this discovery came almost by accident. Atlas wasn't looking for interstellar comets, it was watching for Earth-threatening asteroids. Yet, fate intervened. and the survey's automated algorithms caught something that even the best trained eyes might have missed. In a matter of days, news of the discovery spread across the global astronomy community. Teams raced to collect as much data as possible before 3I Atlas moved too far or disintegrated under solar radiation. The world of science was once again united by cosmic curiosity. For many astronomers, this marked a turning point. It proved that interstellar visitors might be more common than we thought. They're just hard to spot. 3I Atlas wasn't only an object of study, it was a reminder that the galaxy is alive with motion, and that our solar system is not as isolated as we once imagined. But if the discovery itself was surprising, what came next would completely upend expectations. As telescopes peered closer, they realized that 3I Atlas was not behaving like anything they had ever seen before. And that's when things started to get strange. Impossible speed. When astronomers first calculated the velocity of 3I Atlas, they thought there had to be an error. 58 kilometers per second. That's more than twice as fast as most comets traveling through our solar system. At that speed, it could circle the Earth in just 7 minutes. But the data was clear. This was no ordinary traveler. To put it into perspective, even Oumuamua, the first interstellar object ever detected, entered the solar system moving slower than this. Something about 3I Atlas's journey had accelerated it beyond what gravity alone could explain. The question was, what? Some scientists proposed that the comet might have passed close to a massive celestial body, like a neutron star or even a black hole, receiving a gravitational slingshot. Others suggested it could have been ejected from a binary star system, two suns orbiting each other, where chaotic forces could easily hurl objects outward at blistering speeds. But the more data astronomers gathered, the stranger the story became. 3I Atlas's velocity didn't fit neatly into any of these scenarios. Its speed and angle of entry suggested it had been traveling freely through interstellar space for billions of years, untouched by any significant gravitational body. How then had it managed to maintain such extraordinary speed over such unimaginable distances? Could there be unknown cosmic forces at play? Some even speculated about non-gravitational propulsion, a possibility that sent ripples through the astrophysics community. The idea wasn't as outlandish as it sounded. After all, Oumuamua had already shown signs of non-gravitational acceleration, possibly caused by outgassing or radiation pressure. But 3I Atlas was emitting far too little material for such a strong effect. Something didn't add up. Its sheer momentum also meant it was virtually unstoppable. Unlike comets that loop around the sun, this one would slice through our system and never return. Its visit would be brief, but its mysteries could last for decades. One researcher at Caltech described it best. It's like watching a bullet shot from another galaxy, and we've just caught it mid-flight. As the comet continued its high-speed approach, astronomers realized they had only a narrow window to study it before it vanished forever. What they found during that time would only deepen the mystery. Because if its speed didn't make sense, its composition made even less. A comet unlike any other. From the very beginning, 3I Atlas refused to behave like any comet we'd ever seen. While Oumuamua appeared dry and rocky, and Borisov resembled a typical icy comet, 3I Atlas seemed to exist somewhere in between, a hybrid of both, yet distinctly alien. Early spectral readings revealed that its coma, the glowing cloud of dust and gas surrounding its core, contained an unusual ratio of volatile compounds. Carbon dioxide and carbon monoxide dominated, while water vapor was surprisingly scarce. That was strange because water is usually the main ingredient that fuels a comet's activity near the sun. This hinted that 3I Atlas might have formed in an environment drastically different from our solar system. Perhaps in the frozen outskirts of another star where temperatures were so low that exotic ices, not water, became the main building blocks. Even more curious was its age. Estimates placed the comet between 3 and 11 billion years old, meaning it could predate the formation of our solar system entirely. In other words, this object might be a time capsule from an era before Earth even existed. Under Hubble's watchful eye, astronomers noticed something else. The comet's nucleus was smaller than they expected, measuring between 400 meters and 5 kilometers across. That made it far tinier than the brightness of its coma suggested. Clearly, much of its light wasn't coming from the surface itself, but from the vast halo of particles it was ejecting. This behavior was unlike any other comet observed before. Most lose material gradually. 3I Atlas seemed to shed its layers violently, as though it were reacting to sunlight rather than merely sublimating. Its surface appeared volatile, almost unstable, as if some unknown process were occurring beneath its crust. Some astronomers proposed that chemical reactions deep within its core were releasing trapped gases, creating microexplosions that powered its chaotic activity. Others thought it might be breaking apart, fragment by fragment, under the strain of solar heat. Whatever the cause, one thing became clear. This wasn't a dormant lump of ice drifting through space. It was an active, unpredictable force, a relic of another world, alive with motion and energy. And as the data kept pouring in, scientists began to realize that even its light was telling a story they didn't fully understand. Next, we'll uncover why 3I Atlas's brightness has scientists both thrilled and baffled, and how this mysterious surge in light may hold the key to what's really happening inside. The brightness that makes no sense. When astronomers first began tracking 3I Atlas's luminosity, they noticed something extraordinary. It was getting brighter far faster than expected. Between May and June 2025, its brightness surged by nearly a factor of 5, a dramatic increase no model could explain. For an object still millions of kilometers from the sun, this was unprecedented. Ordinarily, comets brighten as they draw closer to the sun because heat causes their icy surfaces to sublimate and release gas. But in this case, the increase in flux, the amount of light energy received, was far greater than what distance alone could account for. The numbers simply didn't match. At first, astronomers suspected a calibration error. Instruments were checked, data was cross-verified between telescopes, from NASA's TESS to TRAPPIST North and South, yet every reading confirmed the same result. 3I Atlas was far more luminous than it should be. This led to one startling conclusion. The comet wasn't just reflecting sunlight, it was generating light in some way, or scattering it more efficiently than any known body. Perhaps the particles in its coma were incredibly fine, allowing them to reflect sunlight more intensely. Or perhaps chemical reactions were releasing energy directly. Adding to the puzzle, its brightness didn't increase smoothly. Instead, it fluctuated unpredictably, sometimes dimming slightly before flaring again. These sudden outbursts hinted at internal activity, jets of gas erupting from beneath the surface, or even collapses within the nucleus exposing fresh, volatile material. One study suggested that 3I Atlas had been active even at 6 astronomical units from the Sun, roughly the distance of Jupiter's orbit. That's far beyond where water ice typically begins to vaporize. The culprit, researchers proposed, might be hypervolatile ices like nitrogen, hydrogen, or carbon monoxide, compounds that can sublimate in the freezing depths of space. If true, this meant 3I Atlas wasn't behaving like a normal comet at all. It was operating on a completely different thermochemical regime, one rarely seen in our solar system. Its internal structure might be composed of exotic ices from regions colder and older than anything we've explored. Each new observation deepened the mystery. Why would an object with so little sunlight exposure erupt with such vigor? Was this simply a natural relic of another star's debris disk? Or was there something more unusual about its composition? Astronomers could only watch in awe as the brightness kept climbing, defying predictions. And soon, a new instrument, one designed to look into the deepest corners of the universe, would provide answers none of them saw coming. The James Webb Revelations. On August 6, 2025, the James Webb Space Telescope locked onto 3I Atlas using its powerful near-infrared spectrograph. The goal, to decode its chemical composition by analyzing the light passing through its coma. What Webb found left astrochemists stunned. The spectrum revealed a complex, layered chemical signature unlike anything observed before. There were clear emissions of carbon monoxide and carbon dioxide, but almost no signs of water, the hallmark of ordinary comets. This indicated that 3I Atlas's activity was being driven by exotic volatiles, substances that vaporize at extremely low temperatures. More intriguingly, the distribution of these gases wasn't uniform. Instead, Webb detected distinct outgassing regions, patches where one element dominated over another. Some areas were rich in carbon dioxide, others in carbon monoxide, suggesting that the nucleus was chemically heterogeneous, a mosaic of ices from different origins. This patchwork composition hinted at a chaotic birth. Perhaps 3I Atlas was formed in the turbulent outskirts of its home system, where different ices and dust fragments collided and fused under extreme conditions. Over billions of years, it may have been reshaped by cosmic radiation and interstellar erosion, becoming the strange, layered object we see today. But one of Webb's most remarkable findings was the behavior of its tail. Normally, comet tails always point away from the sun due to solar wind pressure. Yet, 3I Atlas showed a faint reverse tail, dust moving toward the sun rather than away from it. Scientists theorized that tiny dust grains, heated unevenly, were fragmenting and scattering sunlight in odd directions, creating the illusion of a tail pointing sunward. Others suggested that jets of gas from below the surface might be strong enough to launch particles against the solar wind itself. Either way, it was a visual spectacle, a comet defying one of astronomy's most basic rules. As Webb's data poured in, one thing became evident. 3I Atlas was not just another frozen relic drifting through space. It was active, complex, and perhaps evolving before our very eyes. For Dr. Martin Cordner, the astrochemist leading the Webb study, the findings were both thrilling and humbling. "It's a reminder," he said, "that nature still holds surprises even in the oldest corners of the universe." And as the comet grew brighter and more erratic, scientists realized that the deeper they looked, the stranger it became. Next, we'll see how its nucleus seemed to come alive, twisting, rotating, and changing in ways that challenge our understanding of what a comet truly is. A nucleus that seems alive. As scientists studied 3I Atlas over time, they noticed something even more perplexing. Its rotation wasn't steady. Instead of spinning at a constant rate, its light curve showed irregular fluctuations, as if the comet's nucleus were wobbling chaotically through space. This behavior hinted at a body that was unstable, asymmetric, and possibly fragmenting from within. Initial models estimated a rotation period of roughly 16 hours, but data from multiple telescopes showed small, unpredictable variations. These shifts couldn't be explained by measurement error alone. Something was actively changing 3I Atlas's spin, something powerful enough to alter the motion of an object hundreds of meters wide. The likely culprit? Gas jets. As volatile materials erupted from its surface, they acted like miniature thrusters, each burst changing the comet's momentum slightly. But in 3I Atlas's case, these outgassing events weren't random. They seemed to occur in patterns, suggesting a complex internal structure. Some researchers proposed that beneath its crust lay a network of fractures filled with trapped gases. When sunlight reached these cavities, pressure would build until the ice burst open, releasing plumes of carbon dioxide or nitrogen. This would explain the comet's erratic rotation and sudden flares in brightness. But there was another more dramatic theory. 3I Atlas might be hollow. If its interior was less dense than its outer layers, sunlight could cause the surface to crack and collapse inward, releasing jets from multiple points simultaneously. That would make the comet's motion appear alive, almost organic, as if it were breathing in light and exhaling vapor. One astronomer from the European Southern Observatory described it poetically. "It's like watching an ancient heart still beating, pulsing gas into the void." The metaphor, though poetic, captured the essence of what scientists were witnessing: a celestial body behaving like a living thing. This erratic activity made long-term predictions nearly impossible. Its trajectory, brightness, and spin could change overnight. For mission planners, it was a nightmare. For researchers, a dream. Each change offered a fresh opportunity to understand its bizarre internal mechanics. And as its rotation became more unpredictable, one visual feature began to draw attention from telescopes worldwide: a tail unlike any other. The tail that points the wrong way. By late August, images from the Gemini South Telescope in Chile revealed something that made even veteran astronomers question their instruments. The comet's tail, normally extending away from the sun, appeared to bend toward it. It was subtle but undeniable. Dust and gas were being ejected in the opposite direction of what solar radiation pressure should allow. At first, this seemed impossible. Comet tails form because sunlight pushes gas and dust outward, forming a bright trail that always points away from the sun. For 3I Atlas, the laws of physics seemed reversed. How could dust grains defy solar wind? Further analysis revealed a clue. The comet's dust particles were exceptionally small, even finer than smoke. These microscopic grains could become electrically charged as they absorbed sunlight, allowing electromagnetic forces to influence their motion, sometimes in ways that counteracted the sun's push. This effect, known as radiation fragmentation, might have caused the smaller dust to scatter inward rather than outward. In essence, 3I Atlas's tail wasn't really pointing backward, it was folding in on itself, creating a visual illusion that baffled observers. Still, the geometry alone couldn't explain the full phenomenon. Another possibility emerged. Some of the comet's jets were powerful enough to launch particles toward the sun directly. In this scenario, intense bursts of carbon dioxide and nitrogen gas were propelling dust in unpredictable directions. If true, this would mean 3I Atlas's internal gas pressures were extreme, strong enough to override solar radiation itself. That's like blowing smoke against the wind and watching it move forward. Astronomers began comparing these images to early models of Borisov and Oumuamua, but neither object displayed anything remotely similar. Whatever was happening with 3I Atlas, it was unique. The comet's activity seemed to be increasing as it approached the sun, and researchers speculated that the coming weeks could bring even more violent outbursts. "It's as if the comet is trying to tell us something," one astrophysicist remarked. "We just don't yet know what language it speaks." But the mysteries of its tail were only part of the story. In the following weeks, scientists detected something even more intriguing within its glowing coma, a chemical fingerprint that could reveal its cosmic origins: cyanide. The secret of cyanide. As 3I Atlas drew closer to the sun, scientists began to detect faint chemical signatures emanating from its coma. Using the Gemini multi-object spectrograph, researchers captured a spectral fingerprint that would both excite and alarm them, a distinct emission from cyanide molecules, CN. Hydrogen cyanide, a compound known for its toxicity on Earth, is surprisingly common in the cosmos. It forms when solar radiation breaks apart complex ices, releasing fragments of carbon and nitrogen. In comets, this process usually begins once they reach around 3 astronomical units from the sun, and that's exactly where 3I Atlas was when the first CN signature appeared. But what stood out wasn't the presence of cyanide, it was the amount. The comet was releasing roughly 8x1023 cyanide molecules per second, a staggering number, yet still low compared to typical solar system comets. This meant 3I Atlas was rich in certain volatiles, but deficient in carbon chain molecules such as dicarbon, C2, and tricarbon, C3. That finding classified 3I Atlas as carbon chain depleted, a rare category among comets. On the surface, that might seem like a simple chemical detail, but it carries enormous implications for where and how the comet was born. Carbon chain depletion indicates that 3I Atlas likely formed in an extremely cold, nitrogen-dominated environment, far from the warmth of its parent star. This environment could resemble the edge of a protoplanetary disk, or even the dark frozen voids between star systems. If true, this comet may have condensed from material so ancient and unaltered that it predates many of the planets in our galaxy. More fascinating still, another interstellar comet, Borisov, also showed signs of carbon depletion. That suggests a potential pattern among interstellar bodies. Perhaps these cold, chemically muted objects are the cosmic norm rather than the exception. However, scientists urged caution. The sample size of interstellar comets is still only 3, hardly enough to draw definitive conclusions. Yet, the similarities were difficult to ignore. Could 3I Atlas be a messenger from a particular kind of star system? one that breeds icy, carbon-poor wanderers? As researchers pondered this mystery, they noticed another unexpected clue hidden in its light. The way 3I Atlas scattered sunlight revealed something utterly unique, and perhaps more telling than its chemistry. The strange polarization of light. When astronomers examined how 3I Atlas's light interacted with space, they discovered an anomaly that no comet or asteroid had ever displayed. Its reflected light showed a deep and narrow negative polarization branch, a technical phrase meaning the light waves were aligned parallel to the plane of scattering instead of perpendicular as usual. To most people, that might sound trivial, but for astrophysicists, it was astonishing. Polarization tells us about the size, shape, and composition of dust grains. And in this case, the results suggested that the dust surrounding 3I Atlas was fundamentally different from any known material in our solar system. Normally, comets exhibit positive polarization. Their dust grains scatter sunlight in predictable patterns, producing polarization perpendicular to the direction of incoming light. But 3I Atlas didn't play by those rules. Its light appeared to twist in a way that indicated highly ordered, compact particles, or possibly metallic surfaces hidden within its coma. Such characteristics have only been partially observed in a handful of trans-Neptunian objects and centaurs, which reside in the outer reaches of the solar system. Yet even they don't display polarization this extreme. This suggested that 3I Atlas's dust may have a crystalline or engineered structure, one that reflects light in highly uniform directions. That last point sparked a storm of speculation. Was the polarization evidence of an artificial surface, perhaps something metallic or reflective? Most scientists dismissed that as improbable, but they couldn't deny that the pattern was utterly alien to our experience. Zuri Gray and her colleagues, who published the first polarimetric analysis of 3I Atlas, described it as a class of optical behavior we've never documented before. In simple terms, the comet doesn't just look strange, it acts strange, right down to the way it bends light. This unique signature made 3I Atlas a one-of-a-kind laboratory for studying cosmic dust. Every photon of light bouncing off its surface carried encoded information about its texture and formation, data that could help scientists understand not just this comet, but the materials that shaped other star systems. Still, not everyone was convinced that the explanation was purely natural. In the days following the polarimetry study, one familiar name re-entered the headlines, a scientist famous for asking the most provocative question of all. Could it be alien technology? The extraterrestrial hypothesis. Whenever the universe presents something we don't fully understand, one question inevitably follows. What if it's not natural? Few scientists are as bold in asking that question as Dr. Avi Loeb, the Harvard astrophysicist who has become both admired and criticized for his unconventional ideas. Shortly after 3I Atlas's discovery, Loeb published a paper suggesting that its size and trajectory didn't quite make sense for a natural comet. Early estimates placed its radius at nearly 10 kilometers, a massive object for an interstellar traveler. Given how rare such large fragments should be, Loeb proposed that we at least consider an alternative. Could this be alien technology? In his follow-up work titled, Is the Interstellar Object 3I Atlas Alien Technology?, Loeb and his collaborators explored this idea in mathematical detail. They examined the comet's non-gravitational acceleration, its unusual brightness fluctuations, and even the symmetry of its path through the solar system, all features that might hint at engineered behavior. Their argument drew on the so-called dark forest hypothesis, the notion that intelligent civilizations remain silent and hidden, like prey concealing themselves from predators in a dangerous cosmic jungle. If that's true, Loeb speculated, perhaps interstellar probes like 3I Atlas could be tools of observation, not communication. Silent messengers drifting from system to system, gathering data. Most of the scientific community, however, pushed back. Researchers pointed out that Loeb's analysis relied on early size estimates that had since been corrected by Hubble. The new measurements, between 400 meters and 5.6 kilometers, fell within perfectly natural ranges. Moreover, the comet's acceleration could be explained by gas outflows, not propulsion. Other studies, such as those by geoscientist AKM Eyasanul-Hake, demonstrated that the trajectory of 3I Atlas was consistent with known gravitational forces. There was no need to invoke alien maneuvers when Newtonian mechanics already fit the data. Still, Loeb's speculation served an important purpose. It reminded the scientific community that the unknown deserves curiosity, not dismissal. After all, every major discovery in history began as a strange observation that didn't quite fit the rules. Whether 3I Atlas is natural or artificial, its mystery pushes us to expand the limits of our imagination. And as the debate raged, 3I Atlas continued its journey, growing brighter, more erratic, and more beautiful with each passing day. Soon, it would reach its moment of truth, perihelion, its closest point to the sun. The final approach, and what comes next. On October 30th, 2025, 3I Atlas reached its perihelion, sweeping to within 1.4 astronomical units of the sun, just beyond Earth's orbit. By then, the comet was far too close to our star to be safely observed from ground-based telescopes. For a brief time, it vanished into the solar glare, leaving scientists in suspense. No one knew what to expect. Would it survive the intense radiation, or would it shatter into pieces like so many comets before it? Its growing instability made both outcomes possible. For days, all anyone could do was wait. Meanwhile, a fleet of solar observatories, including SOHO, MAVEN, and NASA's upcoming SPHERE-X mission, prepared to capture whatever traces they could. The world's most powerful space telescopes, Hubble and James Webb, were on standby, ready to resume observations the moment 3I Atlas re-emerged from behind the sun. By early December, it did. Fainter, perhaps smaller, but still very much alive. To the relief of astronomers everywhere, the interstellar wanderer had survived its brush with the sun. Its coma shimmered with renewed activity, a final display of cosmic defiance before disappearing back into the dark. Even now, the data collected from its flyby is being analyzed. Every spectrum, every fluctuation in brightness, every molecule of gas tells a story billions of years old. Somewhere in those numbers may lie the answer to the question that started it all. Where did 3I Atlas come from? Was it ejected from a dying star system? Born from the icy outskirts of a distant nebula? Or perhaps, as Loeb would say, crafted by hands we have yet to comprehend? Whatever the truth, 3I Atlas has reminded us of something profound. The universe is still full of surprises. As it races back into the cold abyss, it leaves behind both knowledge and wonder. Proof that even in the age of powerful telescopes and data-driven science, there are still cosmic mysteries that humble us. Because out there, between the stars, countless other travelers may be drifting. Silent, ancient, waiting to be found. And when the next one enters our solar system, we'll be ready to listen. Until then, the tale of 3I Atlas stands as a reminder that science and curiosity go hand in hand, and that the strangest discoveries are often the ones that bring us closest to understanding our place in the universe. As 3I Atlas fades into the darkness between the stars, it leaves behind more questions than answers, and a quiet reminder of how small we really are. In its icy fragments lie the memories of another world, born under a distant sun billions of years ago. We may never know where it came from, or what secrets it carried, but its brief visit changed the way we see the universe, and ourselves. Because every time we look up, wondering what else might be out there, 3I Atlas reminds us, the cosmos is still full of wonders waiting to be found, and some of them are already on their way.